Okay, so today we're going to start talking about logarithms. First, we're going to start out with what exactly a logarithm is, some of its properties, and then we're going to move on to graphs. So let's start out with what a logarithm is. Okay, so before we answer that question, though, we need to know what an exponential is. Okay, so an exponential kind of looks like this. Let's start with an easy one. Okay, so this right here is called the base. So this exponential has a base of 2. It has a exponent, okay, which is 3, or sometimes you might call that a power. And then it has a value. Okay, so an exponential equation might look like this. Okay, base of 2, exponent of x, and then our values. All right, so an exponential can be a function that describes multiple values, not just one. And it's really, really nice to have inverses of some functions. Okay, so somebody decided to call it a logarithm. So if I were to write this particular expression and equation as a logarithm, here's what it would look like. Okay, see how the base moves down, the exponent or power, and then our value. Okay, now let's do the same thing for the function. Okay, notice that our y, our output, has become our input. And our x value, or our input or exponent, has become our output. Okay, so let's write you a general rule. Okay, exponential. So we have a base raised to an exponent, which is equal to an output. Okay, but with a logarithm, we have the log with the base with our output equal to our exponent. Okay, now the properties of logarithms and exponents kind of mirror each other, so let's talk about those for a bit. Okay, first property that you should know is that a logarithm is the inverse of an exponential. Okay, so if we look at our exponentials, the domain is negative infinity to positive infinity, and our range is 0 to infinity. Now for a logarithm, and these guys are inverses, these are going to switch. So our domain becomes 0 to infinity, and our range becomes negative infinity to positive infinity. Okay. So now keep that idea of opposites in your head as we go through some other properties of logarithms. Okay, so I'm going to keep the exponential column and the logarithm column. Okay, so if I have two same-based exponents, let's do 2 to the third times 2 to the fourth. You would all say that that was 2 to the 12th. All right, see how you add, or excuse me, sorry, I did that wrong. 2 to the 7th. So we add the exponents. Got ahead of myself. All right, now if we're going to do the same thing with logarithms, and I'm just kind of making up some numbers here. See how they're multiplied? I can separate them into addition, like that. All right, so now, let's say I had 2 to the 10th divided by 2 to the 8th. You guys would subtract, right? Okay. All right, so if I have logs that are divided, like that, I can rewrite them. Oops. Like that. Okay. Okay, couple more. If I have a power raised to a power, I would multiply my exponents. Well, if I have the same thing for a log, okay, then I could change it to multiplication, like that. Okay? All right. Here are other couple ones. If I have 2 raised to the 0 power, I get a 1. And I get a 1 like that. Notice that the bases match, like that. Okay? All right. If I have this, I get that. Okay? All right, so that's a very, very, very basic rundown of your properties of logs. A lot of times that you will be asked to solve logarithm equations, and we'll do that in a bit. Other times you will be asked to write multiple logs as a single log, or separate out a single log to a multiple log. So we're going to try doing that for a bit, and then we'll talk about graphs. Okay. Okay, so I see addition and subtraction here, so I'm going to work from left to right. So addition for logarithms will change to multiplications. So I would get log base 2 of 10 times 5 minus log base 2 of 7. So that would turn into log base 2 of 50 minus log base 2 of 7. If I remember correctly, my subtraction will change to division. So I can rewrite that as log base 2 of 50 divided by 7, and then I'm done. Okay? All right. Let's expand. Okay. All right, so I have log base 2 of 50 times x squared times y to the third, all divided by z to the third. Okay, so division changes to multiplication, or division changes to subtraction, sorry. Okay, and all of that multiplication, the 50 times the x squared times the y to the third, that would change to addition. Okay, and then according to the power rule for logs, x power to power changes to multiplication, I could bring all those powers of 2, 3, and 3 down to the front. So my final answer would look something like this. Oops. My z changed to an x. That's always fun. All right, there you go. All right, so next time we will talk about graphing a logarithm and what it looks like.